All right, what's going on, everybody? Gonna jump on here to show you how we're gonna knock out the back wheel. All right, the back wheel's a little bit challenging, mostly because a lot of the dimensions are given in diameters, and because we're gonna try to use the revolve tool, we'll end up using quite a few radius dimensions, right? So the overall plan here is to make this little eye right here. Then we're going to spin it around. Okay, so the real thing we're going for is that we need to understand some important dimensions, right? So there's a lot of different ways to do this. You could do this with extrudes for sure. But in general, if we know that this diameter is a let's go with the outside. This one is 39.2 and this one's 35.2. Well, that means there's 4 millimeters in thickness there, right? We have a width of 15.4 millimeters, 39.2. That's actually a double dimension. That shouldn't be there. Just bad drawings on my behalf. We got 14.6 and then 17.85. Okay, so one of those is to the center. I see. Okay, so let's jump into this. Okay, so something that I'm going to do, because I have all the parts on one, I'm actually going to leave this part on. All right. And you guys are going to get a little taste of what it's like to work with tolerance, right? So instead of us drawing by like with nothing in the background, well, I want the tire to actually fit on this axle, right? Even if it's not in the perfect way, like that's really what we're going for, right? So I am going to have a sketch right on top of this. Okay, so if we think about this, we're going to go from here to here. Okay, so we knew that the smaller diameter was 3, the larger was 6, so that means that we have a dimension of 3. Okay, that one, let's see, we are looking at, looks like it's half of it. We'd go with the assumption that it has to be 4 millimeters. So what I'm saying is we got to do a little bit of math. So 15.4 minus 4. Why 4? Well, if we're going to say that from 39.2 and 35.2, that's 4 millimeters. Well, this distance and that distance has to be the same. So if I take the 15.4 and subtract this 4 millimeters, I'm going to end up with that distance, correct? And that's going to give us a total of 11.4 to cut into 2 places because it's got to be both on the top of this and the bottom of it. Okay, so that puts us at right around 5.7. Okay, so I know this is going to be 5.7 millimeters. Okay, and I'm going to now go up. I know this is going to be 5.7 millimeters. I know this is going to be 4, right? Here, I know this is 15.4. Sorry about that. Okay, I know that this is 4. And again, this is understandably a little bit confusing, so don't beat yourself up if this isn't coming naturally. This is like CAD is hard stuff here. We're gonna come back out here, back to here. I want to zoom in a little bit here, come back to there. All right, so we end up with this eye. All right, we end up with this eye. Now there is some things I'm going to need to change here. That's okay. I want you to see some other ideas. All right. So the last step that I'm going to do before I actually spin this is I want to add one construction line at the center of my axle. All right. And this is going to drastically show you the hurdle if you don't really pay attention to what you were trying to draw. All right. So right now you can see I have some space and I have some kind of freedom between the axle and the wheel. And when we when we revolve this, we're going to end up with a profile right there and an axis right there. That's going to look pretty good to us. All right. The hurdle is that wheel is not going to spin around that axle, right? So although it looks cool and we created a very nice looking wheel, we actually have some problems here because one, we're going to need to cap that. I'll show you how to do that. The other piece is we actually want that to hug, right? We don't want, it's called a limit tolerance. We want this axle to stay on that wheel. So if I go back to my sketch, we want a perfect dimension from here, this axis line, to here, okay? And right now it's at 2. So let's start thinking about this. So if we look at our drawing, we end up with 17.85, 14.6. If we subtract those, you end up with 3.25. All right, and that's a diameter. But 3.25 divided by 2 is really what we want this distance to be because that's what the radius is. Okay, so if I take 3.25 and I divide that by 2, you end up with a number of 1.625. Okay, and you're going to see that this is going to move in. The whole thing moved the wrong way. So let me shift the entire thing down. Let's move this down. Because we want those axles to be exactly right here. Let's move that down to the middle. Let's move this right there. Okay, so now this is really going to be tight right onto that, right? And we have a limit tolerance, okay? And we would have a limit tolerance. We could actually make it drastically different as well, but I just wanted to show you how these parts are interacting. All right, so we can come back through here and put a cap on this if we really wanted to make this perfect. But I just wanted to show you how those two parts are interacting. So this is a little bit of a practice with our revolve tool. But like I said, I'm looking forward to seeing what you do next.